Good morning, everyone. Very happy to be here. Very nice to see so much participation. And noting that last week was the International World Soil Day, so I think this is very apt. So thanks for the introduction, Sharon. Thanks for everybody so far. So today I'm going to be just introducing really about Wild Asia's Biofarm program, and particularly the work we've been doing in partnership with the Centre for Ecology and Hydrology from the UK. So what are biofarms? We get a lot of people are sort of quite confused by us using this term bio, but really biofarms are going back to these traditional production systems where it's all about improving the soil organic matter, improving the microbiology, which we just heard Ms. Heng talking about, and improving the soil conditions to make uptake of nutrients more efficient. Next, Christine. What's the science behind it? I mean, there is a lot of international studies going on. There's a lot of work being done on what's a really quite a new area called the rhizobiome. This is looking at the relationship between the roots of the plant and the soils themselves and the microbiology within those soils. So the rhizobiome is really about how we can improve plant uptake of nutrients. So biointerventions, what we've done so far starts very small. We always believe in trialing something and starting small. So we have worked with a group of growers in Perak initially to set up these biointerventions. They are small areas within an estate or a smallholder. Normally 1 acre trial plots. Next one, Christine, yeah. Apart from the need to have a very strong partnership on the ground with growers, we need also to increase the science and the technological movement towards biofarming. So we've partnered with various organizations internationally, amongst them University of Nottingham, Cambridge, UK CEH, Ithaca, and Ajinomoto for some of the trials in Perak. I'm not going to talk much about that. I'm going to pass you now to Christine, who's going to really give you some of the information that we've gleaned from our work in Perak with the Perak 25 growers, and specifically the work that we've done in partnership with CEH. So over to you, Christine.
All right, thank you, John. So basically, as John had mentioned, so we've been working with some farms in Perak, and we have 25 farms, which we call the Perak 25 or the P25. And together with CEH, we took some soil and foliar samples back in mid-2019. And this next few slides is basically going to demonstrate to you why the soils in our plantations need to be improved in sense of its fertilizer and nutrients. So if you look at the donuts on the left side of the slide, the inner circle is basically magnesium, and you can see that more than half of the plots had a very low nutrient content for magnesium, and that was followed by potassium, and after that phosphorus. If you look at the foliar nutrient content, all of the foliar samples from all 25 plots was deficient in magnesium. This is again followed by phosphorus, potassium, and nitrogen. So nitrogen seems to be the least concern here at the moment, where you can see the whole green part. It's not a problem in most plots. It's actually adequate, both in the soil as well as the foliar. So I suppose what you were saying is that here, the soils in our farms, even though some of the farms are more than 10 years old, are still very, very poor in nutrients, despite being continuously or regularly on a schedule applied with fertilizer, chemical or not. So the next we should also see what we're showing from our soil samples is that the soil carbon content is pretty low in most of our farms. The red color shows very, very low soil organic content. Only about 20% of them have adequate. And surprisingly, there's another 20% with very high organic content. So the very high organic content are basically our plots that are sitting on peat soils, whereas those that have fairly sufficient organic content and those that are deficient are mainly on sandy loam. So we saw within our 25 plots, most of these plots had sandy soils. It's very loose, and it also has very low soil organic content, as you can see, carbon content, you can see on the graph on the right. So put these two together, being sandy loam, being very loose soils, having very low organic content, it's very hard to actually retain the nutrients within the soils. And these are soils that are more than 10 years old, again, as a reminder. So what we need to do really is to improve the organic content within the soils so that the nutrients can better then retain and then being transported to the roots and to the palms. So as Dr. Vijay had already mentioned just now, there's some of the things that you can do, like front stacking for composting in situ, putting in some biochar, also the cover crops. Again, Dr. Vijay was talking about, soil loss and runoffs. So it's very important to have these cover crops to keep the soil more stabilized, or even spraying biojuice to add more microbes to be able to pass along these nutrients into the roots and into the palms. And what we're trying to show here in this graph is that after a year of some bio interventions in our plots, this particular plot, for example, plot number 332, you can see the blue color lines here on the graph is the soil nutrient content in the soil at the baseline when the data was taken in mid-2019. And a year later, you can see the increase, the red color line, in most of the soils and even in the organic carbon content. If you look on the right, the increase in nutrient had also demonstrated in the foliar analysis. More so, like for example, ones where the magnesium as well as the nitrogen was very low, it has increased to an adequate level after just 1 year of biointerventions. And I particularly like this plot 332 because he is one of the few farmers who had removed all chemical fertilizers, herbicides, and pesticides for more than 2 years now. And this is one part of the results that we are seeing. So basically, once you have healthy palms, you have healthy soils, you have healthy palms, you can then start seeing an increase, not even sometimes a big increase in yield, but at least your yield is sustained. What we're trying to say is that by removing these chemicals, we are actually showing that your yield is not going to be compromised. In fact, up till now, even in the first quarter of 2020, this particular farm has still been increasing, has still been performing very well in its yield, way above the average yield for Perak. And what's even more interesting is that since he has stopped using inorganic fertilizers, his cost per hectare has reduced quite significantly, in fact, by 30%. This is because now he's not using any chemical fertilizers, he's not using chemical herbicides, pesticides. And overall, you can see when compared to a conventional farm, the one in blue, his farm may have, now that it's chemical free and he's using biointerventions, are still getting about the same revenue per hectare. But look at the expenses per hectare, it has reduced. By having that reduced, then his gross profit has then increased by 33% more than the conventional plot. So that is quite impressive. So that's just with 25 plots that we're working in Perak. And by 2025, Wild Asia is working very, very hard to try and provide support for more farms across at least 3 of our palm production regions. So we're talking about Sabah, Sarawak as well. And we are aiming by 2025 to have at least 5,000 hectares of these biofarms. It may seem a little bit ambitious, but the results for the last 2 years has been very, very promising. And we've already actually expanded. Now, other than the Perak smallholders, the P25, we've already got 3 estates in Johor as part of this program. We've also got 5 smallholders, 2 growers, and 1 estate in Sabah working along with this biointervention program. So that's all from us. Thank you, Sharon.